Bonsoir, mesdames et messieurs. Good evening, ladies and gentlemen. My name is Sung-Hoon Kim, and I'll be your host for today's event. This is day 4, session number 20 of ICAO's Air Navigation Conference SkyTalk series. Today we have a treat for you. We learned in session number 18 that there was a change leading to this. Let me see. When I was younger, I remember when I came to Canada for the first time in 1975, we had a television set, and I had to go in, turn on the TV, and change the channels for my father. And then I remember the first wired remote controllers where you had up-down, on-off, mute, and volume up-down. And I was so happy. And then we saw VHS and Betamax come in, so I didn't have to do that anymore, right? But then we also had CD, Blu-ray, HD, DVD, Apple TV, Roku, and so on. The problem is there's no standardization. There's no standard. And when you talk about standard, you have words like you hear words like innovation, technology. Low price, what else? Backward compatibility, affordability, interoperability. All of these things are important. But what we learned earlier in session number 18 is that we saw a clear transfer from aeronautical information service to aeronautical information management to SWIM, which is the system-wide information management, because of the enormous amount of data that is coming to us. Now, Wayne Osse, Chief Architect, Global Aviation and Transport at Solace, is going to explain a little bit more how his organization is dealing with this wave of change and how they are a leading contender in the global market. So if you please, welcome Wayne Osse. Thank you.
Thank you. Thanks very much. Sorry. So I want to explain a little bit about who Solace is first, and then I'm going to go into the SWIM area and SWIM core messaging, which is really where we play. Solace is based in Ottawa, Canada. It's a global entity. We have cross-industry as well. We have not as big a company with 250 people, but we focus just on this one thing, which is really messaging. We started in about 15 years ago, mostly in finance, and I'll talk a little bit about that in a second. But we're also in many other types of verticals. Aviation started about 6-7 years ago with some work we did with Harris originally. So just to give you a little feeling for where Solace is used, and we're sort of this quiet company in a way. It's a company that is used, but people don't know it's used in some cases. So in payments we're used, so American Express, if you swipe your credit cards, those messages are going through Solace, for instance, right? You wouldn't see that, but that's going on in the background. In aerospace, the GOES-R, GOES-S weather satellites, which are really GOES 16 and 17, sort of the GOES East and West for the weather service in the US. Those satellites were being managed command and control using Solace. And that's sort of our first foray into aerospace. That's really very little traffic as far as messaging goes. It was really just all about reliability. They have multi-billion-dollar satellites. They needed to have extreme redundancy, so that's where we started. Also, let's say another example, let's say you have a phone that most people have, which I don't want to go into the name, but basically every time a new phone would come out from this one manufacturer, their online store would go down. I just couldn't take the traffic, right? So this is a place where Solace is used now, and that doesn't happen anymore. In smart cities, we're used in Asia for some smart cities in Singapore, the LTA. It's for all the buses, all the data coming from buses, for instance, comes into Solace and is distributed from there. Connected cars, another area. This is more of IoT, or at least coined as IoT now. That's really an area where it's very interesting how you have, let's say, 20 million connected cars all the time, and you have to address a single car occasionally and say, I want to send a message just to that one car, and also scaling at the same time to 20 million. There's also the, in the aviation area, the FAA via Harris initially. We've been there for quite a while. I've been involved in those. That's from the beginning. We started out solving some problems with fan-out in messaging that's basically trying to send data to a lot of consumers. We solved that problem, and then we started being used for distribution within the National Airspace System, among other things, including SCDS, which is a hybrid distribution service coming out in a few months. Online betting turns out to be a pretty stressful system. There's a lot of bets. Some bets are actually quite large. And that's an area in Asia and Europe that we're very involved in. Also, positive train control in the US is one of our bigger customers for almost 10 years now. Basically, every time they put a segment in for positive train control, it's about 150 million messages a day. So it kind of builds up, again, sort of the heavy lifting we do. So as far as what we offer, and I'll go through a little bit about what our products are, just so you can see like what it is, because we only do this one thing. We're basically message brokers, so it's queuing, request reply, streaming, pub sub, publish subscribe. Some of these are the paradigms in SWIM, in the standards for SWIM, and we have various protocols that we offer. And then we can work in different sort of modes in terms of hybrid in a fabric or a federation of systems. So the three sort of flavors of what we have is appliance, and this is where the reliability comes from. These appliances, this is how we started in finance, is basically programmed FPGA chips and network processors, sort of like an IP router, if people are familiar with that. So if you think about messaging and you think about IP networks, sort of like an air traffic network, those networks are built on hardware typically, although today there's software-defined networks and so on. This is just elevating messaging to a hardware infrastructure piece. So it makes it extraordinarily reliable, and it's very high performant. And those two things together are quite disruptive. It's not common that you see those two together. And then there's software versions of the offering as well. And then there's also the cloud offering. So these can also be mixed and matched and federated among each other. The way we get involved in a lot of these messaging systems is it may be a combination of these. We also have a unified management for this as well, so that you can manage the entire thing. So the idea is you basically have Solace, right? That's the idea. So you don't have to worry about this part of the infrastructure anymore. And of course, encryption and authorization, authentication, all of the things that you typically would expect in a hardened system are available too. So I'm just going to do a quick shot of this. This is sort of our appliance. There's a few cards involved in this. So you think of it like a control plane, data plane. This is sort of the IP router kind of mechanism. We speak in terms of egress and ingress, just like you do in routers in networking. There's network blades, there's topic routing blades, which are doing like 12 million topic matches a second, and also our HA mechanisms for having high availability. A couple models. This will be more for reference for people, but the world here is in microseconds, not milliseconds and not seconds. Right? This is point to point, like 50 to 100 microseconds for guaranteed messaging, that kind of thing, and upwards of hundreds of thousands of messages per second. Let's say 2K. So if any geeks in here as far as messaging, they might understand what that kind of means. The software is deployable in many different forms, Docker, KVM, Almies, and Amazon. It's in the marketplace. So it's available in many different places, and you can mix and match these as well as far as federation. And then we are offering this in the cloud as well. So you can let us manage it, and we can offer it as well. And you can also federate this with your on-prem instances. So this is actually something that's coming out. It's actually in early access, but just to give you a feeling for kind of the federation that we can do with Solace. And this is for SWIM or any other kinds of messaging. The idea is that you can run instances in different places, let's say different public clouds, on-prem, private clouds, and federate them. This is a mechanism which is available in a sort of a best effort messaging form today, but this is available now, starting to become available now in guaranteed messaging or persistent messaging where you don't lose anything. And the idea is that you have sort of a data aware fabric so that if someone's subscribing to something in one region, so let's say there's some air traffic and there's two different ANSPs involved. Maybe the first ANSP, where the plane is leaving from, is interested in some data from an airport that is, at the destination airport, just to give an idea. Then and only then will that message actually be sent over, right? So it's not a request reply. It's actually a subscribing, declaring your interest in something, and then that data goes. So this prevents you from overusing your WAN pipes or any kind of network bandwidth that you have. So it's basically sort of a smart, I wouldn't call it machine learning, but it's sort of a smart messaging fabric for guaranteed messaging. So there's some other supplemental pieces to Solace, Hybrid Edge, which sort of helps with integration, messaging APIs, which I'll show in a second, the open APIs and protocols. Now this goes to standardization and SWIM. There's standards for SWIM, standards for like IoT, those kind of things. We're quite big into the open standards. And then the micro gateway, which is really all about REST, which is one of the SWIM standards in yellow profile. So this is our API world. You can see there's AMQP on there. AMQP 1.0 is part of the yellow profile. And then you have REST as well. And then all of these protocols are sort of mix and match. You can push a message in on one of these protocols and receive it on the other. So if you have an AMQP system that maybe has a back end that's JMS, you can use it that way. And this is just quickly the hybrid edge thing. So I want to get into we talked about unified administration and seamless security. This again is sort of the federation you can have and the integration with different systems. We realize that you have to have existing systems that have to be able to work in the ecosystem. How do you interoperate with all of these things? They're all a reality, and then there's some that probably will come in the next month that you don't even know exist. And so those have to be integrated as well. So this is the picture, if anybody came by the booth earlier this week. This is sort of my picture, my sort of modification of the ICAO's layer cake, or the next-gen US layer cake. Typically, you see the network or the ATN on the bottom level, and then you'll see the yellow section right above it. I've split the yellow section into two pieces. There's really the messaging layer, and then there's the layer above it, which does more of the business logic or transformations, mediation, that kind of thing. This is typically how we see architectures across industries, where the messaging layer is a separate entity to itself. It's also something you can swap in or swap out by itself, which gives people the freedom. And the way you do that is through these standards like SWIM. You have AMQP 1.0 and REST. If you support those, you should be able to swap this out and swap in another solution, right? And this is also where you get a lot of this federation, where you're connecting multiple systems across a WAN or across the globe. So our genesis at Solace is really with the global investment banks, and they're typically in Hong Kong, London, New York, Tokyo, and so we've been doing this federation for quite a long time. So we've had to deal with the different kinds of qualities of service of different WANs, which varies quite dramatically. So we've been working with different ANSPs, and there's sort of various sort of deployment models for this. It's not that complicated, really. It's just that wherever there's a message broker, you would put this SWIM compliant type of message broker in there. Sometimes, like in the FAA, they have their own stack. They have a whole bunch of series of systems, and they just replace the message bus and leave everything else in place. Sometimes it's more core to the entire system, and then in which case it's a bigger deal to change it. But if you're following these standards, you really shouldn't have too much of a problem doing that. So a smaller ANSP, let's say, in an ideal case, would probably have an instance that's a primary and an instance that's a backup. There's this HA triplet you see there is for the software. The hardware has a pair. This is just one example where they're using the software instead of the hardware. Now, you do sacrifice some reliability when you go to software, but it's an option, and it is quite reliable by itself. But having two different locations is kind of key, because for disaster recovery, you really need another location where you have your backup, right? In the case of Solace, you can have both sides active, and they can back each other up. And that's a built-in feature even in the software that we have. A larger or typical ANSP might have the hardware for the reliability reasons, but they also may have some cases where they want to have software in different places, and then they federate that across. So if you think of the dark green boxes on the outside as ACCs, let's say, and the two boxes in the middle may be ACCs, maybe not, and they're communicating with each other, maybe replicating across to back each other up, but basically distributing the data and going geographically across to all of the other instances. So you could have, let's say, hardware in some places where it's needed for reliability, like 5 nines. The software could be somewhere where maybe it's not quite as critical or the load's lower. And then if you don't want to have any instance there, then you can have remote client connections as well, which is why some of the boxes don't have anything in them. So there's nothing wrong with doing that remote kind of connection. And then in the case of a larger ANSP, where it's kind of geographically diverse and there's larger central type nodes, then it just becomes a little bit more of a central mesh. Again, you can switch out, you have software or hardware where it makes sense. Typically, UTM is a lot of times the UTM systems are pulling data off of SWIM systems if the SWIM systems exist, so that's where they're getting fed. They have to integrate with the National Airspace System somehow. And then you'll notice on the bottom, for instance, there's a little Amazon Web Services box there. So going hybrid into Amazon is another example of shifting your infrastructure somewhere else. And if your messaging system can federate like this, that's actually a really easy thing to do. You can just bridge out to an instance in, let's say, Amazon, and distribute from there, which is precisely what the FAA is going to be doing in a few months. This is just sort of a little more detail around a hybrid kind of mechanism where you have different feeds. Now in the US, this would be what they call studs or FTPS and so on, just being mirrored over into an Amazon equivalent, let's say, and then being distributed from there or managed from there. So really you can go to either site, let's say, to get the data, but the feeds each have their own tunable TCP connections across the WAN. And then you just have to send one copy in, and then you're sending multiple copies out. So this is sort of a holistic view of partly where Solace is involved, and also, partly where a lot of the ATNs exist in the world. There's always probably different variations of this, but as you can see the little satellites there, that's where Solace got involved initially. And then there's some work we're doing in the Americas in general. And also there's later on, which is kind of interesting, the GOES-R, GOES-S, we're not really shipping images around, just for command control. But then the Car Astro is a company that's actually got dishes. They're listening on the GOES-R and GOES-S satellites. They're taking the images and they're redistributing them, and they're using our Solace Cloud to do that. So it's kind of interesting. We've got different kind of ecosystem there that's using our product. And then some of the regional efforts that are going on in South America and Asia, we're getting involved in as well, trying to provide resilient messaging infrastructure. So as I said before, in terms of a SWIM infrastructure, it can benefit from this sort of disruptive capability of having high reliability and performance. So far, the performance requirements in this space have not really stressed the Solace products very much. But I think that's going to change over time. It's more about the reliability. And I talked about some of the different places we've been used before. So that's kind of a repeat. But we really do support a lot of robust mechanisms like the disaster recovery. I mean, that's something I could talk to for about 2 hours all by itself. Asynchronous and synchronous mechanisms for distributing data to another backup site. It's pretty powerful. And so for SWIM specifically, the reliability, of course, like I said, this is a NASA NOAA proven thing for GOES-R. We've done some things around security to provide certificate, verification. beyond just the normal client-server certificates, encryption, Kerberos, and so on, to make an ecosystem more viable in terms of security and PKI. The hardware compression and also in software is actually quite critical, especially with some of the smaller pipes that are existent in some countries that can actually have, especially with XML, which is used for all of the SWIM messaging. It's a pretty good compression rate, even with simple compression mechanisms. So that's actually quite a benefit. And then we're starting to do, in bridging at least, between sites, is having the security with the compression. This is a big deal in North America, actually. So this is something that's, it's recent, but it's allowing something like the SCDS system to be realized. And then the open protocol is key. AMQP 1.0, REST, JMS, which is heavily used in the FAA, MQTT, which is an open wireline as well. So open wirelines, if they're not familiar, basically open wirelines mean that you should be able to take a product and take it out and plug something else in, and it should just work. We've seen that with MQTT with our product specifically. AMQP is a little trickier, but because there's certain things that aren't specified, but it's a relatively straightforward thing, and we support the Cupid APIs on top of AMQP 1.0, so you have some standard APIs to use. And I think I've talked about the other things already. Yes, so bad behavior. We don't like bad behavior. Bad behavior is sort of the norm. Participants who use, maybe they're offline, maybe they're consumers and they're offline, they build up a lot of data. Maybe some applications are disconnecting constantly because they were designed badly. Or just there may be something wrong with the network, it's flapping constantly. All of these kinds of things, Solace has been built to deal with these things. Being able to have consumers behave badly and then consumers and producers that are behaving well, they shouldn't be penalized. And so there's a lot of effort that we put in to prevent things from affecting other things in the ecosystem. And it's actually quite difficult to do, but it's something we focus on because, again, this is all we do at Solace. So one of the things that I think is important to know, besides the reliability, but it's really de-risking your messaging system. So my past is I've developed messaging systems myself, but that was a long time ago, and you really don't need to be doing this anymore. It's basically cooked. And there's no reason to be spending time developing things like this when you can just use something that does it so well. So that's, do you really need to manage that code and deal with it yourself? So that's just one perspective, I guess, we have. So we've been involved in SWIM for quite a while in the States, and then in Eurocontrol now we're involved. And we're trying to have a positive effect on how these systems are built, even if they don't use Solace. And then we do use, I call it SAIL. It's sort of an innovation lab that we have in Amazon that's used we take sort of the FAA R&D feeds and we use them for trying out different ideas and playing around, basically. So if you want to play with Fixum or Axum or something, it's something that's useful. And we've used those demos to sort of be a genesis for ideas at the FAA and other places. And then the global aviation standards, of course, SWIM, work more focused on yellow profile, but one thing to keep in mind is if you think that yellow profile is for slow things or pedestrian messaging, if you think of it that way, if you think about Solace, if you're using the hardware, you could do hundreds of thousands of messages a second with AMQP, so that's not exactly slow. So if sort of a paradigm shift in your mind, the message broker is no longer the bottleneck, it's actually the applications are. And then hardware as a service is something that we're looking closely at as well, some way, offloading the infrastructure, kind of like in Amazon, but with Amazon you're in a shared environment that doesn't necessarily have the same reliability level, so we're investigating that kind of concept with around the world, actually. And so this is sort of the last bit. I call it total cost of loss. Everybody talks about total cost of ownership. But what happens if you lose something? How important is it to you? Now, myself, I come from finance. When they lose something, they could lose 2 minutes of data, could be billions of dollars, right? So, and And they go to quite extremes to make sure things don't fail. But in this environment, and this is why I gravitated to this environment, is because it seems like the cost of loss is so much higher, right? And it's something that I don't think people necessarily focus on, but it is really important. You know, if you lose just one piece of information, how important is that to you, right? It could affect a lot of stuff in this environment. So I think it's a good exercise for people to think that way. And it's something in finance we do all the time, but it's always about money, right? And that's it. Any questions? Any questions? No? It's Friday afternoon, Friday evening? Okay. All right, well, thank you very much. Thanks.